So we're given this polynomial, and they tell us that we can rewrite this as the equation of an ellipse. So I want to use complete the square to make that happen. So the first thing that I want to do is actually spread it out just a little bit because I want to change some things. And so I want a little room to work. So I make a little more room here. And then I start thinking about what I can actually do to complete the square. So when I look at 4x squared plus 8x, what I really want to do is get that 4 out. So if I divide everything by 4, I'm left with x squared plus 2x inside parentheses. Bring down this plus. And now I think in terms of that 3y squared plus 12y. Now here again, I want to take the 3 out. So I want the 3 away from everything else. And then what I'm left with is y squared plus 4y. Inside parentheses. And finally, the last thing is over here, I've got plus 4 equals 0. And I really want that 4 gone because it's just a distraction for me. So I'll subtract 4 from both sides, and then I get equals negative 4. Now, when I come back to this 4x squared plus 2x, what I really want inside these parentheses is a perfect square trinomial. So the number that I have to add to the inside of this is actually a 1. So this is where I have to be extra careful because I've got a 4 on the outside and I just added a 1. And the reason that 1's there is because now x squared plus 2x plus 1 is a perfect square and I can take the square root. But by putting this 1 here, 4 times 1 is 4. I'm actually adding a 4 to this side. So I have to go to the equal sign, and I've got to add a 4 over there as well. Because what you do to one side of an equal sign, you have to do to the other side to have balance. So to balance out that 4, I'm going to add 4 on the other side. Now, in order to transform this, the y terms, into a perfect square trinomial, y squared plus 4y, I actually need to add a 4. But when I add that 4, I keep in mind that I have a 3 in front. 3 times that 4 is actually 12. So I'm adding 12 to this side of the equal sign. So in order to maintain balance, I need to add 12 to the other side as well. Now that these are perfect square trinomials, I can write them as a product of squares. So I can say 4 times the quantity x plus 1 squared plus 3 times the quantity y plus 2 squared. equals, and here we just sum these together. 4 plus 12 is 16, and 16 minus 4 is 12. Now, since I know that this entire thing needs to be equal to 1, I'm going to divide everything by 12. So as we divide, we just simplify the fraction of 4 over 12. 4 over 12 is the same thing as 1 over 3. So our denominator becomes a 3. When we go to the y's, y plus 2 squared, we have 3 over 12, which 3 over 12 is the same thing as 1 over 4. And of course, at the end, 12 over 12 is actually a 1. And that's how we rewrite this equation as the equation of an ellipse. And we get x plus 1 squared over 3 plus y plus 2 squared over 4 equals 1. Now we want to go through and graph this using two different methods so that we always know that we can graph this ellipse no matter what form it's actually in. So the first method to graph this function is, well, it's not a function, it's an equation, is to actually go to my graphing calculator, menu, graph entry edit, equation templates, and I want to go all the way down to conics. So the general equation for a conic, I can actually take the values that are here. So I've got 4x squared. I don't have an xy term, so I'll just put 0, plus 3y squared, plus 8x, plus 12y, plus 4 equals 0. And that is my ellipse. So there's my equation. Everything's all set, and I'm good to go. But now I can actually test the equation that we created. So I'm going to press menu, graph entry edit, equation templates, and I'm going to go to the ellipse template. Now notice, my ellipse is already here. So now I can put my new values in. So I need that to be plus 1. So I put in a negative 1. I need that to be plus 2. So I put in a negative 2. And finally, my denominator, I need this to be 3, so I have to take the square root of 3. I need this one to be 4, so I'm going to put in 2 squared. Press enter, and notice we just verified that both of these ellipses are the same exact graph. So if I toggle back and forth, you see how I'm taking either one. And now I can take a picture of this graph and put it in my document. And from this graph, I can identify the key points that I need. My center is -1, -2. The major axis, right? The major axis is up and down. So here I'm going to take the x is -1, and the minor axis, left to right, y is -2. And that's how we can use complete the square to determine the equation of an ellipse.